In the previous year, we have already discussed the force between two masses, that is gravitational force. We know that gravitational force is always attractive, but in the case of force between two charges, it may attractive or repulsive. When we are placing two positive charges, they repel each other. If we place two negative charges, they repel each other. One is positive, another one is negative, they attract each other. Okay, that all things we have already discussed. So let us discuss the force between two charges. How we calculate the force between two charges? Already we know that there is a force between two charges. It may attractive or repulsive. So Coulomb's law states the force between two charges. It states that, let us just go through the statement. It states that the force of interaction between any 2 point charges. What do you mean by point charge? Point charge means the size of the charge is very less than compared to the distance between the charges. The size of the charge is very less than compared to the distance between the charges. Then we can call it as point charges. So the force of interaction between any 2 point charges is directly proportional to. So there is a force of interaction. It may be attractive, it may be repulsive. So this force of interaction is directly proportional to product of their charges or product of the magnitude of the two charges. So that is, consider these are two charges Q1 and Q2 separated by a distance R. Then we can write F is proportional to Q1 into Q2. It is directly proportional to product of their charges, and it is inversely proportional to square of the distance between two charges. So here, what is the distance between these two charges? That is R. So we can write F is proportional to 1 by R square. F is proportional to 1 by R square. So the force of interaction between any 2 point charges is directly proportional to the product of the magnitude of the charges, that is F is proportional to Q1 into Q2, and inversely proportional to the distance between the charges, that is the distance between the charges can be taken as R. Then we can write F is proportional to 1 by R square. And acted along the line joining the two charges. It is always act along the line joining the two charges. Listen. So this is the line joining the two charges. So it always act along the line joining two charges. Okay. So by combining this, so we can write F is proportional to Q1, Q2, and F is proportional to 1 by R square. By combining these two equations, we can write F is proportional to Q1, Q2 divided by R square. Q1, Q2 divided by R square. Then, to change this proportionality into equal to, you have to multiply with a constant. Then we can write F is proportional, or F is equal to a constant into Q1, Q2 divided by R square. F is equal to K Q1 Q2 by R square. So which is that constant? That constant can be taken as K is equal to 1 by 4 pi epsilon 0. The constant can be taken as 1 by 4 pi epsilon 0. So it's a new term, that is epsilon 0. So consider these two charges are placed in vacuum. Okay, then what is this epsilon 0? The constant epsilon 0 is called permittivity of free space. What is that? Permittivity of free space. It is the permittivity of free space. What is the value? The value can be taken as epsilon 0 is equal to the constant, the value of permittivity of free space is equal to 8.85 into 10 raised to minus 12. So that is epsilon 0 is equal to 8.85 into 10 raised to minus 12. Okay, so when we apply this value into this equation, we will get the value of k is equal to 9 into 10 raised to 9. Wait, let us after discussing this, let us write the units. Okay, wait. So epsilon 0, the value of epsilon 0 is equal to 8.85 into 10 raised to minus 12, and the value of 1 by 4 pi epsilon 0 is 9 into 10 raised to 9. So the constant is k, it is 1 by epsilon 0, its value is 9 into 10 raised to 9. Then this equation will become f is equal to 1 by 4 pi epsilon 0 into q1 q2 divided by r square. So the force between two charges is given by F is equal to 1 by 4 pi epsilon 0 q1 q2 divided by r square. So from this equation, let us find out the unit for epsilon 0. So we know that take this epsilon 0 into left side. Then epsilon 0 is equal to 1 by 4 pi f q1 q2 by r square. So which is the unit of q, that is Coulomb. So q1 into q2, that is Coulomb square. So we can write Coulomb square by force is the, okay, so we can write the unit of force is Newton. So Newton raised to minus 1. Here r square is the, so we can write as meter raised to minus 2. So this is the unit of epsilon 0. The value of epsilon 0 is equal to 8.85 into 10 raised to minus 12 Coulomb square Newton raised to minus 1 meter raised to minus 2. Same way, let us obtain the unit for k, that is 1 by 4 pi epsilon 0. So listen, this comes to this side, that is fr square by q1 q2. Then how we write? That is Newton meter square Coulomb raised to minus 2. So the value of k is 1 by 4 pi epsilon 0 and it is given by 9 into 10 raised to 9 Newton meter square Coulomb raised to minus 2. So the force between two charges placed in vacuum is given by F is equal to 1 by 4 pi epsilon 0 q1 q2 divided by r square. Okay. So we have already discussed about the force between two charges when it is placed in air or vacuum. So next we are discussing the electrostatic force between two charges when it is placed in a medium. For example, we are placing two charges in water. So what is the change in the force? What is the difference in the force? Let us discuss that. So we are placing two charges. One is Q1 and other one it is Q2. So these two charges are placed in a medium. Okay, then the distance between these two charges can be taken as r. So according to Coulomb's law, this force is directly proportional to product of their charges and inversely proportional to the distance between them. There is no change. So we can write F is equal to K into Q1 Q2 divided by r square. But when we place it in a medium, there is a change in the value of k. The value of k is equal to 1 by 4 pi epsilon. So what is that? It is 1 by 4 pi epsilon. So what is epsilon? What is epsilon? Epsilon is the permittivity of medium. The last we discussed about epsilon 0. That is epsilon 0 or epsilon naught is the permittivity of free space. So here it is the permittivity of medium. So what is epsilon? It is the permittivity of medium. So we can write this F is equal to 1 by 4 pi epsilon. So we are placing in a medium. So we can write Fm, that is Fm, force in medium. That is 1 by 4 pi epsilon Q1 Q2 divided by r square. The force in a medium is given by 1 by 4 pi epsilon 0 Q1 Q2 divided by r square. So when we place in an air, when we place it in air, it will become 1 by 4 pi epsilon 0 Q1 Q2 by r square. 1 by 4 pi epsilon 0 q1 q2 by r square. When we place in a medium, it will become 1 by 4 pi epsilon q1 q2 divided by r square. Okay. So next, let us discuss another term, that is dielectric constant or relative permittivity. So we have already discussed about permittivity of free space and permittivity of medium. Then what is relative permittivity or dielectric constant? What is relative permittivity or dielectric constant? So dielectric constant is defined as the ratio of the permittivity of the material, that means medium, to the permittivity of free space. So what is that? The dielectric constant or relative permittivity can be taken as epsilon r. The relative permittivity is equal to permittivity of medium, that can be taken as epsilon m, or we can take it as epsilon. We can take it as epsilon. So what is that? It is the permittivity of medium divided by permittivity of free space. So what is that? Epsilon r is equal to epsilon divided by epsilon 0. So this is called the dielectric constant or relative permittivity. From this we can write that what is epsilon? Epsilon is equal to epsilon 0 into epsilon r. What is epsilon? Epsilon is equal to epsilon 0 into epsilon r. Okay. So we have already discussed about the force acting between two charges when it is placed in air. So let us recall it. What is that? When we place two charges in air, the force is given by F, so we can give it as F naught. That is 1 by 4 pi epsilon 0 q1 q2 divided by r square. F0 is equal to 1 by 4 pi epsilon 0 q1 q2 divided by r square. Then what is the force when it is placed in medium? That is Fm is equal to 1 by 4 pi epsilon q1 q2 divided by r square. Fm is equal to 1 by 4 pi epsilon q1 q2 divided by r square. So instead of this epsilon, we can give this epsilon 0 epsilon r. Epsilon 0 epsilon r. Then how will be it? That is Fm is equal to 1 by 4 pi epsilon 0 epsilon r into q1 q2 divided by r square. The force in medium is given by 1 by 4 pi epsilon 0 epsilon r q1 q2 divided by r square. Then what is this 1 by 4 pi epsilon 0 q1 q2 by r square? That is force in air or force in vacuum. So we can write that is Fm is equal to F0, that is force in air, divided by epsilon r. What is that? Divided by epsilon r. Epsilon r is the dielectric constant or relative permittivity. Then the force in a medium is given by F naught, F0 divided by epsilon r. That means this is the force in air. When we place two charges in air, okay, there will be a force that we can take it as F naught or F0. We are replacing that two charges into a medium. Then the force is given by Fm is equal to F naught by epsilon r. My question, when we change the medium between the two charges, what happens to the force? Force increases or decreases? Here the value of epsilon 0 epsilon r is greater than 1. Then we can understand that from this equation the force in medium decreases. Okay, when we place two charges in a medium, the force between the two charges decreases. From this equation we can find that is Fm is equal to F naught by epsilon r. Keep in your mind, when we place two charges in a medium, the force between them decreases. Okay. Next, let us do one question from this part. From electrostatic force or Coulomb force. So that is, what is the force between two small charged particles having charge of 2 into 10 raised to minus 7 Coulomb and 3 into 10 raised to minus 7 Coulomb placed 30 centimeter apart in air. So, two charges are placed in air. It's a direct question. So, we have the two charges. One is Q1. What is the value of Q1? That is 2 into 10 raised to minus 7 Coulomb. And what is Q2? Q2 is equal to 3 into 10 raised to minus 7 Coulomb. 3 into 10 raised to minus 7 Coulomb. Q1 is equal to 2 into 10 raised to minus 7 Coulomb and Q2 is equal to 3 into 10 raised to minus 7 Coulomb. And they are placed 30 centimeter apart in air. So, what is the value of R? The distance between two charges, that is 30 centimeter. Okay, you have to convert that into meter. So, how we convert into meter? That is 30 into 10 raised to minus 2 meter. So, what is the force? Force can be written as, it is placed in air. So, what is the force? F is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R square. The force is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R square. We know the value of 1 by 4 pi epsilon 0, that is 9 into 10 raised to 9. So, that is F is equal to 9 into 10 raised to 9 into, what is the value of Q1? That is 2 into 10 raised to minus 7 into the value of Q2 is 3 into 10 raised to minus 7. So, 2 into 10 raised to minus 7 and 3 into 10 raised to minus 7 divided by R square. The value of R is 30 into 10 raised to minus 2. So, we can write 30 into 10 raised to minus 2 all square. 30 into 10 raised to minus 2 all square. Okay, then next find out the values. That is F is equal to 9 into 2, 18, 18 into 3, or we can write as 18 into 3, it is 54 into 10 raised to 9, 10 raised to minus 7, 10 raised to 2, then 10 raised to minus 5 divided by 30, that means 3 square, that is 900 into 900 into 10 raised to minus 4. That is F is equal to 54 by into 10 raised to minus 5 divided by 9 into 10 raised to minus 2. So, what is the last answer? 54 by 9, that is 6. The force is given by F is equal to 6 into 10 raised to minus 3 Newton. So, 10 raised to minus 5, 10 raised to minus 2, then remaining 10 raised to minus 3. The force is given by 6 into 10 raised to minus 3 Newton. So, the force between two charges is given by 6 into 10 raised to minus 3 Newton. Okay. So, let us do one more question. So, here the electrostatic force on a small sphere of charge is 0.4 microcoulomb. Due to another small sphere of charge minus 8 microcoulomb in air is 0.2 Newton. The force is given. The electrostatic force between two charges is given. That is F is equal to 0.2 Newton. And which are the two charges? One is 0.4 into 10 raised to minus 6 Coulomb. And what is Q2? What is 10 raised to minus 6? It is microcoulomb. So, we can write as 10 raised to minus 6 Coulomb. So, what is the value of Q2? Q2 is equal to 0.2, sorry, it is minus 0.8. So, we can take that is minus 0.8, that is minus 0.8 into 10 raised to minus 6 Coulomb. So, you have to calculate the distance. What is the distance between two spheres? So, you have to find the value of R. So, which is the equation? That is F is equal to 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0 Q1 Q2 divided by R square. So, how we find the value of R square? That is R square is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by F. So let us calculate the value, that is R square is equal to 9 into 10 raised to 9 into, what is Q1? Q1 is 0.4 into 10 raised to minus 6, that is 0.4 into 10 raised to minus 6 into minus 0.8 into 10 raised to minus 6 divided by, what is the force? Force is given by 0.2 Newton, so that is 0.2 Newton. Okay. Then the value of R square is equal to, this is can be cancelled, so it will become 2, 0.4 by 0.2, that is 2, then 2 into 9, that is 18, then 18 into 8, what is the value of 18 into 8? 18 into 8, that is 4, then 6, 1 into 8, that is 144. So what is the answer? That is R square is equal to 14.4 into 10 raised to minus 3, 14.4 into 10 raised to minus 3. That is R square is equal to, we can write like this, 144 into 10 raised to minus 4. 144 into 10 raised to minus 4. Then what is R? R is equal to root of that value, that is R is equal to root of this one, that is 144, that is 12 into, what is 10 raised to minus 4, that is 10 raised to minus 2. Root of 10 raised to minus 4 is 10 raised to minus 2. So we can write that is R is equal to 0.12 meter. Okay, the distance between the two charges is given by R is equal to 0.12 meter. Another question, two equal balls having equal positive charge Q coulombs are suspended by two insulating strings of equal length. What would be the effect on the force when a plastic sheet is inserted between these two? So there are two charges suspended by two insulating strings of equal length. Then what happens? They repel due to a force. Okay. Then even we place it in a, that means that what would be the effect on the force when a plastic sheet is inserted between two? We are placing a plastic sheet between these two charges. That means the medium between these two charges changed from air to plastic. Then we know that what happens is force, its force decreases. We have already studied that. Its force decreases. That is, in the air we can write as F is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. When we place plastic, then it is Fm is equal to 1 by 4 pi epsilon 0. It is not epsilon 0, 1 by 4 pi epsilon. 1 by 4 pi epsilon. That is in medium Q1 Q2 divided by R square. We have already studied that. What is Fm? That is force in medium is equal to F naught by epsilon R. So the force decreases. So what happens to the force? The force decreases. Okay. Next, another question. Plot a graph showing the variation of Coulomb force versus 1 by R square, F and 1 by R square, where R is the distance between the two charges of each pair of charges. So both cases you have to draw the graph between F and 1 by R square. So we know that the equation to calculate force is F is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R square. So here force is inversely proportional to R square, or we can write F is proportional to 1 by R square. So you have to draw the graph between F and 1 by R square. So there are two cases, one is 1 microcoulomb and 2 microcoulomb, and next it is between, the force is between 2 microcoulomb and minus 3 microcoulomb. So let us take the first case. Okay, so both are positive. The force also will be positive. So how will be the graph? they are directly proportional. That means here it is 1 by r square. Keep in your mind, it is not r, it is 1 by r square, and this is f. So how will be the graph? They are proportional. The graph will be like this. The value of force is positive. The second case, 2 microcoulomb minus 3 microcoulomb. Here it is 1 microcoulomb, 2 microcoulomb. The force will be positive because positive into positive, the force will be positive. Then the second case, second one. What is the second one? One is 2 microcoulomb and another one it is minus 3 microcoulomb. So they repel each other. That means the force, they attract each other. That means the force is negative. The force is negative. So we can write how we draw the graph. The graph will be like this. So this is the force. This is 1 by r square. This is 1 by r square. When r increases, what happens? So 1 by r square, the graph is like this. The force is negative. When 1 by r, the value of 1 by r square increases, the force also increases, but it is negative value because 2 microcoulomb and minus 3 microcoulomb. So this is the graph between force and 1 by r square. Okay. Next, one more question is when the distance between two charged particles is halved, the Coulomb force between them becomes. When the distance between two charged particles is halved, the Coulomb force between them. Consider which is the equation to find Coulomb force, that is F is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by r square. The force between two charges is given by 1 by 4 pi epsilon 0 Q1 Q2 by r square. In the question it is mentioned that the Coulomb force between them, the distance between two charged particles is halved. So this r become r by 2. Then listen, the new force will be like this. F dash is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by r, means it will become r by 2. It is halved, that is r by 2 whole square. So what is f dash? F dash is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by r square by 4. So this will become f dash is equal to 4 into, comes to this side, that is 4 into 1 by 4 pi epsilon 0 Q1 Q2 divided by r square. That is f dash is equal to 4 into 1 by 4 pi epsilon 0 Q1 Q2 by r square. So what is 1 by 4 pi epsilon 0 into Q1 Q2 by r square? That is the force here, the initial force, that is 1 by 4 pi epsilon 0 Q1 Q2 by r square. Then we can write f dash is equal to 4 into f. The value of f dash is given by f dash is equal to 4f. That means the force increases by 4 times. Okay, the force increases by 4 times. So let us move to the next topic, that is related to Coulomb's law. That is vector form of Coulomb's law. So what is that? Vector form of Coulomb's law. Previous year we have already studied about these vectors. So we are writing the vector form of Coulomb's law. Consider two charges, one is Q1 and the second charge can be taken as Q2. This is the first charge and this is the second charge. When Q1, Q2 is greater than 0, the force is repulsive. Why? Q1 into Q2. When Q1 is positive and Q2 is positive, they are like charges. Positive into positive, it is positive, that is greater than 0. When both are negative, like charges, Q1 is negative and Q2 is negative, negative into negative, it is positive, greater than 0. When Q1, Q2 is greater than 0, then the force between these two charges will be repulsive. Okay, then let us take these two charges. What is the force acting on this? Q1, Q2 is greater than 0, that means it is repulsive. The direction is along this, that is the force acting on the first charge due to the second charge. So here the force acting on the second charge due to the first charge. So F12 is the force acting on the first charge due to the second charge, and here is the force acting on the second charge due to the first charge. So because this force takes place along the line. Okay, that is one is F21 and other one it is F12. Then I am just introducing another vector, that is R12. So what is R12? It is the vector directed from 2 to 1. R12 is the vector directed from 2 to 1. Then what is R21? R21 is the vector directed from 1 to 2. R21 is the vector directed from 1 to 2. Then previous year you have studied unit vectors. What is unit vector? Unit vectors are used to represent the direction of a vector. Okay, so how we write this unit vector? So we are writing unit vector, that is R12 cap is equal to, unit vector is equal to vector divided by magnitude of this vector. What is that? R12 cap is equal to R12 vector by magnitude of the vector. And what is R21 cap? R21 cap is equal to vector R21 divided by magnitude of R21. So listen, R21 cap is equal to vector R21 by R21. So what is this? It is directed along the direction of R12. So we can write the unit vector R12. The unit vector R12 is directed from 2 to 1. What is that? It is directed from 2 to 1. What about R21? The unit vector R21 is directed along this vector R21. That means it is directed from 1 to 2. So it is from 1 to 2. So we can write like this. So unit vector R12 act along this direction from 2 to 1, and the unit vector R21 acts from 1 to 2. Okay, then let us find the force acting on the first charge due to the second charge. So what is that? That is F12 is equal to 1 by 4 pi epsilon 0. So the force acting on the first charge due to the second charge is given by 1 by 4 pi epsilon 0 into Q1 Q2 divided by R12 square, that is the magnitude of the vector, R12 square. Listen, this F12, the direction of F12 is from 2 to 1. Okay, so unit vectors are used to represent the direction. So how we represent this? F12 is acting along this unit vector, that is R12, because the F12 is from 2 to 1 and R12 is also from 2 to 1. So we can write this unit vector like this, that is F12 is equal to 1 by 4 pi epsilon 0 Q1 Q2 R12 square R12 cap. Okay, what is next? What is the force acting on the second charge due to the first charge? That is F21. That is F21 cap. What is F21 cap? It is equal to 1 by 4 pi epsilon 0. F21 vector is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R21, the magnitude square of this magnitude. Okay, that is R12, sorry, it is R21. R21 square, it is along the direction from, it is directed from 1 to 2. So which is the unit vector along 1 to 2? That is R21 cap. So we can write as R21 cap. So first vector is directed along r12 cap and the second vector f21 is directed along r21 cap. Here listen, these are two unit vectors. One is directed from 1 to 2 and the one is directed from 2 to 1. So we can write like this. What is r21 cap? The r21 cap, they are equal and opposite. We can write like this, that is r minus of r12 cap. R21 cap is equal to minus of R21 cap because R21 is directed from 1 to 2 and R12 is directed from 2 to 1. So they are equal and opposite. So we can write R cap 21 is equal to minus of R12 cap. Then what is F12? We can write this F21 vector is equal to 1 by 4 pi epsilon 0. Q1, Q2 divided by the magnitude of R12 and R21 will be same. So we can write R12 square because R21 magnitude of R21 is equal to magnitude of R12. Then we can write it is directed along R cap, that is R21 cap. This R21 cap is equal to minus of R12 cap. So what is that? It is minus of R12 cap. So what is F21 cap? We can write F21 is not cap. What is F vector F21? That is equal to 1 by 4 pi epsilon 0. Q1, Q2 divided by R12 square, this minus will come to this side, then remaining R12 cap. So what is 1 by 4 pi epsilon 0 Q1 Q2 R12 square R12 cap? It is equal to force acting on the first charge due to second charge, that is F12 vector F12. So we can write F21 vector F21 is equal to minus is the minus of F12. So what is F21? F21 is equal to minus of F12. That means these forces are equal and opposite. It means that the forces are equal and opposite. It obeys the Coulomb's law, obeys Newton's third law. Because the forces are equal and opposite, Coulomb's law obeys Newton's third law. So for the examination, you may have to prove Coulomb's law obeys Newton's third law. How we write? You have to obtain this equation by the vector F21 is equal to, that means the force acting on the second charge due to the first charge will be equal to negative of the, that means they are in opposite direction, negative of the force acting on the first charge due to the second charge, because they are equal and opposite, because so that it obeys Newton's third law. The Coulomb force obeys Newton's third law.